Hey everybody, how are we doing? We should be live on YouTube right now, so let's see who's all in the chat. We're going to start some activity here in a moment, but if you are here, feel free to say hi, making sure just everybody, good stuff. Announced it in the Discord, announced it online. We're going to start the assignment here soon. Let's go get the assignment. Anna, good to see you here. Anna, thank you so much for being here. Let's throw out some UBOT points. Wilton is here. Let me go to live chat. Perfect. Now I can see the live chat. Hate how it does that. I think we're good. Manage moderators. That's new. Angelique, good to see you here. Shiv, good to see you here. Let's throw out some 50 points. 50 points for everyone being here. Lillian, good to see you here. Well, awesome stuff. We're going to go here to BAS 320. Go over to the modules. Rachel, good to see you. And let's go down here to activity number 1, R basics. And here we go. Wait, this is assignment. It's an assignment. Assignments and activities are going to help you out with going through and practicing. Let's go and take a look. Here we go. So this is the first activity. Please feel free to ask questions while we're doing this. You don't have the solutions yet. They will appear here shortly. But we're going to download this. Now, this is a DAT file, which is basically like a data file. It's like a CSV or an Excel file. So just think of this as a spreadsheet. Like all this file is right here, which is not going to look just like this. But this file you see on the screen, that DAT file, it might as well be this. Does that make sense? Let's get some yes or no's in the chat that the DAT file is basically just data. That's all it is. Yes or no's in the chat. Like, oh, that's a data file. It's like, cool. And so we'll see what the chat says. What does chat say? That's just a data file. That's just data. Might as well just be called data.dat. Nice job, Jacob, right there. 20 points. But what is this RMD file? What does RMD stand for? And please ask questions at any point. Thank you so much. All the participation is awesome. You're welcome, Daniel, anytime. We got to practice. We got to practice. This is a new thing I'm doing this semester, like just for 320, just review sessions here. We got a data file. We got solutions PDF. Let's go to student view. Student view right here. Let's go look at those solutions. Oh, solutions are locked. Oh, we should leave student view, right? So you can't see the solutions yet. That's an R Markdown file. Angela getting everyone another 20 points. So what the heck is an R Markdown file? We're going to download these files here and open up the R Markdown file, which you should have R installed by this point. What the heck is an R Markdown file? An R Markdown file stands for R Markdown file, and RMD file stands for that. And if you can see, we'll zoom in so you can see really closely right here. It's got the RMD on it. Now, this differs from an R script, which is only used to write what? What is the only thing you do with an R script? Like, this is the only thing you do with an R script. This is called an R script right here. So this is an R script. Do you see the blue? That's that. And then this is an R Markdown file. This is how you make new ones. So this is only used in our script, which I have right here. That's in our script, is only used to do what? Which is okay. I do them all the time. In our script is only used to do what? Who knows? 20 points in the chat. Who knows? Like if you have an R script, which I use all the time, you're only doing this. So if you have an R script, you're only doing this. Does anyone know? You're doing what we do in the class is what you're doing. If you have an R script, all you can do is write what? It's giving me the figures error, which is fine. If you have an R script, all you can do, you can only do this. I hate that it does that sometimes. We could write here all this. Only code. Great job there, Angelique. Great job. 20 points. Don't worry if you're wrong. Don't worry if you're wrong. This is just your chance to practice and just be like, okay, so an R script is used to write only code, but an RMD file has the mark. You see how the things up here change? Watch. You ready? You see this? Look at me. Now look at you. Look at me. Now look at you. It changes because an R Markdown file has the additional options to knit. And what does it mean to knit something? Well, this is going to turn it into a document. So I might be able to knit this. Let's see. I'm going to turn it into a web page. So when you knit it, hey, Dan, good to see you here, Dan. We're knitting this into a web page right now, and boom, we've created a web page. There you go. You just made your first web page right here. So as everyone see, we have now created a web page from this file. You won't create web pages. You could create, you'll probably do Word documents. I would suggest that right here. But this is like knitting it. You're taking it and knitting it into a Word document. So you're taking all of this code right here. Now you do have the option to code, and where are your options to code at? What are these things called? Hint, they're right here. What is this? It's like a gray area with a play box next to it. This is a what? What is this space called? This space right here is called a what? It just doesn't have that option, Daniel. Great question. So this is an RMD, which has the coding part. So this is a code chunk. Daniel, 20 points. Great questions. So in RMD, great Charlie right there, this is a chunk. So you can add more chunks. You see it has this C right here. C stands for chunk, and you can add chunks. You can even do Python if you want. You want to code some Python? You can code Python. You don't need to, but you can if you want. You want to code RCPP? You can do that. SQL, Stan, we stan our code. So you can go right here and code in R by putting in R chunk. Notice how R is kind of on its own because you're coding in RStudio, so they kind of think you're going to want an R chunk. So these are R chunks. Don't worry about making changes. This is the title of the chunk, and you can actually search through the document. You might not have known this. I'm kind of going over some basics right now. Please keep asking questions. But this is like a kind of index right here, or a, what am I looking for? Table of summary, table of contents. That's what I'm looking for. It's like a table of contents. And you see that unlabeled chunk? I'm just going to call this Chunk Brian. And notice right there, we got Chunk Brian. So if you're down here in your document, you can go back here and go to Chunk Brian like that. One of the great things, and we're just doing the basics right now to make sure everyone kind of understands, like, what are we viewing? These chunks are where we write code. These portions right here, you should think of just like what's. When you look at this right here, you should think of this not as code, because we're in an RMD. You should think of this just like it's a what document. Who has advice? 20 points in the chat. When you look at this right here, you should think, oh, that's just kind of like a blank document. Like, I've used this a million times. I can just type whatever I want right here. It doesn't matter. This is not code. This is basically a Word document. You are correct. Great job right there, Daniel and Rachel in the chat. Now, I want to point something out. You can make it look more like a Word document by going up here in the corner and just clicking this. Watch this. You ready? Magic. Magic that takes a little while. With clicking this button here in the top corner, which is something new, I think, around RStudio recently, you'll see that it actually looks a lot more like a Word document now. And I did not know how to spell basically. Spell check did not appear till a few years ago. You can even go here now and even bold stuff a lot easier, italicize, underline, all this stuff. Now, when you go back to look at it inside of R, it will look a little bit different because it's going to represent it with like LaTeX coding and stuff, but you can still run all your code viewing it through the Markdown editor. So a good thing to know, and I don't know what that button does. Hide document. I'm not going to click that. This is the Markdown editor right here, which lets you see what your document will look like when you knit it, and you can see even better that these are code chunks. This is the code chunk option for the chunk of code you've created. We a lot of times don't change the basic options. You can choose whether it'll evaluate when you knit, whether it'll show the code when you knit. We won't go through all the options right here, but here you go. You can show warnings. It's set to its default. So now it's set to false, and we can just put it back towards the middle. There we go. You can show your messages, you can use all these options, and you can choose different things here. We don't deal with that much, but that's the options for how R will handle this chunk. This plays all chunks above, like any chunk above, like this Brian chunk. If I do 2 plus 2 right here, and I run this above, that'll run the 2 plus 2 chunk because the 2 plus 2 chunk is above it. This is the run current chunk over here. So this will play the current chunk, which just has this save into X 1/2. Who's following along? And I want to pause to see if there's any questions right here. What questions do you have right now? Because I've covered a good bit of the basics, and we'll go back to the main editor right here, just the way it usually looks. What questions do you have? Did I do that? What questions do you have? What are you thinking? Is it starting to make a little more sense? This is just the basics. I might make a cut in the video, like understanding what R is, like understanding what you're seeing right here. Like, this is where we write our code. These are all comments. That's actual code. These are comments. How are we doing, everybody? Talk to me. Tell me, what do you think? Surely there's a question or two. This is like a Word document where we can do code, which is awesome. We'll see what people say. I'm going to throw some points out to the chat. Get everyone talking. Tons of points if you're here. What do people think? Sometimes Mubot can see the future. Over here, which I use R scripts a lot, you're just only writing code. Over here, you have the option to write code and make a Word document. So it looks like we're good. I'm going to put a cut in the video and we're going to come back and start doing some assignment work right here. See, I made a whole mess of everything right here with all this, but don't worry about that. We'll just delete this off right here. We'll just delete that off. Did I do that too? Oh, I think I did. I'm going to change this back right here. Oh my gosh. There we go. So let's put a cut in the video and let's start solving some problems right here. Here we go. Cut in the video. Okay, so that was our basics. Now let's talk about writing some equations, which is on this week's assignment. I think it's some of the first stuff we're going to do here. We're going to take equations and then solve them inside of R. So the way to do this is to do it in little bits. Oh, the volume's too low. I guess you guys might hear that properly. Little bits. Let's go work through some little bits of the equations right here. So at this first part, we're just solving or storing into, kind of read it as a sentence. We're going to take x right here and store into it 1/2. So you might have already said this in class. Sorry if I missed it, but is there a difference between the assignments and the activities? Yes. The activities are basically a quiz, and then you'll answer like individual questions on them. And the assignments are just straight assignments. So just like you turn it in, you have to work through everything, you have to explain things. But the activities are more like multiple choice. So it's like your first one you did on the first week, where you have to answer questions that are like, what is the answer to this? And it's like 5, and you enter it in. And if you get it right, you get full points. What are all these things with, we see this right here. What are all these hashtags right here? We should know every little bit as we go across this. What's the deal with the hashtags right here? What's the deal with hashtags? So why do we have hashtags next to our code? We're adding what's to our codes. Comments, great job right there, Shiv, 20 points, great job. Adding comments to the code. This is like your assignment now, where we have to write this as an equation. Now, this is LaTeX right here. This is LaTeX, which you don't have to learn LaTeX, LaTeX. Great job right there, Zachary and Rachel, commenting on the code. We're going to take this x squared over x minus 1. So I want people to follow along. I just want you to write the easiest thing. I just want you to do x squared right now. All I want you to do is write x squared in the chat. I'm going to write the same code you are. I'm just going to tell you what to write, or I'm going to just ask you what I should write next, but I just want you to write x squared. We're going to solve that equation. We can see the answer. How do we write x squared? As code. And then we're going to run it. We're just going to run little bits. Little bits. Little bits of code. How do we write x squared? Be practicing along. Be trying to do this as I say it. I'll show you the steps. You're right, Charlie, right there. Great job, Charlie. X squared. Now, the next step is to do the bottom part of the equation. Now, don't look at this. This will try to trick you. We want to do this. We're going to divide by what? Now, be careful. I want you to tell me exactly what I should write next. And great job, William, Anna, Lillian, and Charlie. What should we write next? But I need be careful. I'm kind of giving a hint. Because if you don't do it, it might not solve correctly. And so we already have x saved as 1/2. Great job, Charlie, right there. Yes, and Daniel. Excellent work. X minus 1. Now, does it matter if I do like this? Does this matter? I wouldn't do this, but does this matter? Parentheses are important. Great job right there. Does this matter? Does this matter at all? No. R reads through spaces. So the spaces don't matter. So don't worry about that. Doesn't matter if you put spaces. R will handle it and read it the same way. One question down. Let's go on to the next question right here. Ooh, this is a mess. This seems like a really tough question right here, but all I want you to do in the chat is I want you to write this right here. Do you see this? I just want you to write this right here. Be very careful. In the chat right now, try to solve this, and I'm going to show you how to solve this really easily. I want you to only write this portion I'm hovering in the chat right now, and I'll solve the rest of it. So your goal is to only write this. And I'll show you what I'm going to do right here as you're figuring out how to write that. So while you're figuring out how to write that right now, I'm going to take this portion right here. And what I'm going to do is I'm going to take all of this right here and reassign it to Y. So I'm just going to take all of that. Oh, everyone's doing the EXP. Well, you know what? We could do that. We could do that. Everyone's doing the EXP right there. That's not a bad idea. Everyone's doing that, you know? Why don't we do that? Why don't we just do that? I like that. And so let's talk, because some people are probably wondering. So E is not part of R. Good. Anna, let's throw Anna some 20 points right there. R doesn't know E. Just give it a try. Be like, okay, E. And R says, I don't know what E is. E is exp1, which is a function which takes E and raises it to the power of 1. Does that make sense right there? That it's E raised to the power of 1. And I see Charlie caught the star right there. Great job, Charlie. So this is going to give us E to the first power. It just literally solves for, I'll draw it right here so you can see it. exp1 is equal to E raised to the first power. So we want to put these powers into this area right here, which is where 1 is. So we're just going to replace 1 with whatever we have up here, which is minus 0.7. Now here's where the error occurs, and don't worry, I actually didn't notice it that it was there, and Charlie caught it. This is an error. Try running it. It says no. Now the reason is because it thinks 1.2x is like an object or so. It just can't find it, an unexpected symbol it's saying rather. We need to put a star right here to multiply the two together. Even though there's no star right here, just because you can write 1.2x, you have to put a star to multiply together these two things. So think about this. Now that we have this, let me reassign this as y. And now I want you to write the equation that we have. Just think about this. I just assigned this to be y. This is y, and this is y. So that you should see the answer. Be very careful, because you might forget a parentheses on the bottom. So who can rewrite this equation right now that we've basically just taken and said, okay, that thing's y. Oh, shout out to Shiv, 20 points right there. Charlie, think of that positivity. Shiv just doing great right there. Getting the correct answer. Thank you, Shiv. Awesome work. So how would we rewrite this now where we've just made this y? So it's E raised to this. That literally is this. And then we just have this is y, 1 plus y. I basically said the answer. Once again, if you listen, you're like, hey, that's y, so that's over 1 plus y. Be careful, parentheses on the bottom. So who can put it in the chat right here and figure out, great job right there, Daniel. Awesome work. And it's just like, once you hear it a few times, you're like, oh, wait, there we go. Is this helping? Let me ask. I can slow it down. I can speed it up. What are people thinking right now doing the activity? Is it making more sense to break it into parts, to be like, let me just solve out the top of this equation, assign it to the value of y, and then we've literally just made y over 1 plus y, because y is this. Like, this is y. We have created this. We've stored into this. And I do want to point out, hopefully we're not going too quick, but right here, this stores into. Really helpful, Anna. Great to hear that. Yep. And please ask those questions any point you're stuck, especially maybe you come to one later and I'm going too quick. Just be like, hey, Brian, slow down. Slow down. I don't get it. That's all right. That's all right. But Anna, thank you so much. Right here, we are saving into y. This stands for save into. The most basic thing to look at is saving 5 into y. And then we could just say here, y times y. What is y times y? You know this. We'll put it in the chat right here. I'll throw the points in. If you know what y times y is, you get that amount of points. What is y times y? I'll give you a hint in the chat. Y times y would be what right now? I've overwritten what y is. I've assigned 5 to the value of y, and I've said, what is 5 times 5? Well, that's why. See, even my brain converts it into what it is. The answer is 25. Great job, Anna, right there. One of my favorite jokes, which I do in our class, or I've always said, what is 2 plus 2? And you can tell your friends, what is 2 plus 2? Does anyone know what 2 plus 2 is? You say to your friends, I'm using my computer program to figure out what 2 plus 2 is. And my computer tells me that 2 plus 2 is what? 2 plus 2 is what? Because we've stored into 2 the value of 1. So now 2 plus 2 is what? Frankly, 2 plus 2 can be anything you want it to be. Because now 2 plus 2 is... It better not be 2. 2 plus 2 is 2! That's what we're teaching you here at Business Analytics at UT in the Haslam College of Business. 2 plus 2 is 2. Because 2 is 1 and... It's just the object 2 is 1. The object 2 plus the object 2 is equal to 2. Do you recommend assigning a vector and writing it like you did with y? I often think that's good, especially if you have bigger equations or something repeats. Just creating objects and using those, it can help. You could write the full thing out just to show it. Since this is y, here's the full solve. So let me put them side by side. Here is the reduced version. We'll put a comment. reduced version, and here is the full version. Either one's fine. It just is easier to look at, like this thing repeats. So I personally like the reduced version, but you could just, since this is Y, I just put what that was right there because that's Y. So hopefully that makes sense. Great questions right there, Daniel and everybody and Charlie. How did you do that shortcut where you changed the Y to the whole thing? I might have been copy pasting. Change the Y to the whole thing. I'm trying to think. I might have done a copy paste. I probably went over this, and then I think this was it right here. I did this. Yeah, I did a copy paste. I think I started asking out. Yeah, it was a quick copy paste. Control C, Command V, or Control C, Control V. I know all the keyboard shortcuts. I hope that's jokes. And no one knows all the keyboard shortcuts. Not even Bill Gates. He doesn't even know all the keyboard shortcuts. You're welcome, Daniel. Thank you so much for asking those questions. Keep asking. Sometimes I do something really quick and I forget. Okay, here's a pretty fun one right here. With this one right here, we are writing this equation, but it's a bunch of nested things. You ever see those nested dolls that kind of go outward? I want us to only work on the innermost portion of this and only write the very most inner. How can I get this error? It says X not found. Here, Angeli, do this. X, do that right there. That should fix it. X was not assigned to the value of 1/2. Good question, Angeli, 20 points. Think of this as one of those dolls right here, those nesting dolls, and tell me how we would solve just this. And this is a tricky thing. You think ln, let's just go for the obvious. Okay, ln x, no function ln. No function ln, we're stuck. Now, what is ln? ln stands for natural log. Natural log is log base e. So what actually is going on right here is we need the log of x, and the, wait a minute, what's that saying right there? It says that it is doing, well, where'd it go? Let's write it again. So let's go here, log. There we go. If you see what it says right there, it says log of x, and Charlie's got it right there. We can put x in, that's just an object like log of 10, but that's base e. If you see what it says when it pops up that message, like Excel will do for you, it's showing you that this is using a base exp1. And once again, I'll show it. I wish I could just pause it and screenshot it right there. There we go. That's excellent. It's using the base, which is going to be the value by which we take the log. And we are going to have right here exp1, which is e, if you remember from earlier on. So with this right here, that's natural log. It might even say something about it being natural log on here somewhere. But this is going to do natural log by default. If you don't want natural log, like log 10 of it, you could go, not leg, log, oh my gosh, base equals 10. And now we have done the base 10 log of x. But to confirm, does this make sense? Like the base 10 log of 100 is 2. What would be, I'm going to throw a 50-point question right here. What would be the base 4 log of 16? Log 16 base 4. What would this be? Who knows how to do logs really well? This is not what we do in business analytics. William, great job right there, earning everyone 50 points. You are very correct. It is 2. Because the question is, what power do you raise 4 to get 16? So the answer is 2. If you did something like here, like 64, you'd have to raise it to the 3rd power. And if you did 256, you'd have to raise it to the 4th power. Those are the powers of 4 right there. 4 to the 2nd power, 4 to the 3rd power, 4 to the 4th power. So when we do this right here and we put in x, this is the base 4 of x. Well, that's very interesting. And then here is the base e. And that's natural log. So this is the natural log right now. But now, what do we need to do to it next? Say, Brian, take the what of this. Think about the next thing around it. Because we're almost done. We're 2 steps away from done with this one. What's the next thing around it? So, Brian, now we need to take the what of it next. So we've already got the natural log of it. So now we need to take the absolute value. Now watch this. Here's a trick. If you highlight code and do a parentheses, you put the code in parentheses. The same works for quotes or brackets. If the code is highlighted, you can put it in parentheses. It's a great trick. ABS, well, there's the absolute value of it. And now we're almost done. There's 2 ways to do this. Great job right there, Rachel, Shiv, Daniel, Angeli. Awesome work. I'm going to highlight it again. And what would you like me to put around it? This one's interesting that it does exist. There's 2 ways to do this right now. I'll show both ways. You don't need both ways, but you can if you want. So what's one way I could do this right here? Because we need one more thing around it. We just did the ln, we did the absolute value, and now we need a what around it. We're doing great on the assignment or activity. Log 10, great job, William, right there. Great work. Yep, log 10. So we can do it this way, which is the right answer, or, and this is the right answer too, we can go log and then put a second argument and go base equals 10. Notice how this gives the same answer. You're just using the log function and assigning the base or using the log 10. And so Daniel pointed out right there, you can go log and then it's confusing a little bit because this, you could do this. Ooh, we got thunder outside. Watch this. I could call this X now. Ooh, we already are using X. Let's call it Y because Y is not being used. And we could go right here and assign this to Y. And this is the inner part of it right here. I just reassigned that to Y. And then we have the same value. So we're just taking the log of Y using base 10. Or if you want, you can just make it look like this. We could probably do log 10 or exactly. Great job right there. And then a big thing to point out, I want to make sure everyone knows this. Every time I put a comma, I'm putting a different what in R. These are key terms to know. Here's a function, and this function has in it 2 whats. So this is a function, and this is the first blank, and then a comma separates it from the second blank. Every time you see a comma, you should think, oh, it's kind of a new thing, like take the log of this and do it at base this. So every time you see a comma, that's a new something. And so it's a key term like, oh, put in another blank to tell it to do something else. So every time you see a comma, we're doing a new something with functions. What would it be right here? Commas are new R. Kind of like an input, it'd be a new argument. I think we've got the thunder here now. Great job, Wilton, right there. A new argument, 20 points in the chat. A new argument. So if you notice right here, this is the first argument. What are you taking the log of? And the second argument is what base do you want? I oftentimes like to use examples like this, like a dinner function that says something like pizza. And then the second argument might be like 1900. So think about this. The first argument is, what are we having for dinner? So we are having pizza. And that's like an instruction for it, like make pizza at 7 p.m. So this is a function right here that won't run. And we could just put it in a comment now and just say, random function. So that is just a random function that doesn't run right there. Just fun. Well, that's how to do mathematics in R. Let's start a new section right here. And please ask all those questions. I put a $sign. What? No, we don't want $signs. Okay, we're about to do some data sets right here. So get those questions ready. Great job, Angeli and Shiv and Wilton and everyone. This is just some practice right here. I'm going to mark these videos afterwards, especially with these cuts right here. Let's hop in and start working with some data. Let's do this. So what we have right here is the Act 1 cust trans data, or DAT. This is, once again, we talked about it earlier, just a data file. It doesn't look like, we'll show what it looks like in a second here, but just think of an Excel file. I know this is a jump file, but it's just a data file. It's just data. We're going to open it up, and we're going to work with it, and we're going to analyze it. It's going to have variables. It's going to have observations. To load in data, there's a bunch of ways to do it. You'll see this in class. But if you notice right here, I'm going to run the code. Now, I want you to think about why this didn't load the data. Hint, it's not going to work. Sometimes I purposely do things wrong, and then I fear people think I don't know what I'm doing, because sometimes I do things wrong. Why did this not load the data? Why did this not load the data? Oh man, it's giving me another error. Error attempt to use zero link vector. Where's that giving an error at? Ooh. Why is it not loading the data? Hint, here's your hint. I don't see the data loading in. Boom, right there. Rachel, you got it. It probably says that in the instructions. Rachel, great job. Rachel earning right around 50 points, telling me exactly what to do. It's currently a comment. It was currently a comment, so it wasn't loading in. So if you run it now, it loads. You can clear your global environment, which just like wipes your brain. Because remember, this is the brain of R. Here's the brain. It's just like Harry Potter. It's all gone. Let's just load in just this data right here and watch. It's going to appear up there. There it goes. There's the data. And I am hitting Control or Command Enter. So I'm hitting Control or Command Enter on my keyboard. Hold Control and hit Enter. Or Command Enter on a Mac. You can also run the current chunk by running the chunk here. That'll just run the chunk. And you can also highlight code to run code and run it like this. I just want to show these options because the earlier you learn things and incorporate them into what you're doing, the better you get at coding. If you're like, oh, I can highlight a line of code and run it, we're good. You can also highlight individual things like this right here. If the power goes out, I'm sorry, it's thundering outside. So with this right here, this is basically an Excel data sheet. And I want to say this. Has anyone started looking at the activity yet? Who's looked at the activity? Because you're about to be like, psh, I got this. Who's looked at the activity so far? Because I think some of the questions are like, what column is industry in? Could anyone tell me what number column? I'm stuck on this part. That's awesome, William. Especially ask some question, be like, hey, Brian, what column is industry in? If you can see up there, we can kind of tell where industry's at and super industry's at and all these different columns. This is a data frame inside of R. Data frames have inside of them vectors. And it looks just like an Excel spreadsheet. Think of just an Excel spreadsheet. Great job, William, right there. How do we import the file? Make sure you have it downloaded from the assignment. So make sure you have this downloaded and in your working directory. If you're stuck on this, let me know. Stuck on 2B, we'll be doing 2B very soon. Great job, Shiv, right there. So make sure you have this downloaded in your working directory along with your RMD. If you're getting that it can't find the connection, like if you run this right here, I'll put an extra S and it says this, then both of them are not in the working directory, or there's a typo or something. Like I purposely made a typo so it couldn't find it. But now that this is the proper file name, ooh, what's going on my keyboard? Now that, oops, that's bad. Now that this is the proper file name, it will load in. If it doesn't load, then it's not in your working directory. Check your files and make sure it's in there, and I can work with people to make sure this is working. So let's go ahead and start looking at the questions. Was question A just loaded in? Oh, look at the rows and the columns and the dimensions and all this good stuff right here. Then first show the 4 lines. Okay, so we got some tasks. Task 1, dimensions. Task 2, columns. Task 3, rows. Task 4 and 5, start, and end. So the dimensions is a rather quick function right here called DIM for dimensions. And we can just get the dimensions of the data frame by going here. And can anyone take a guess at what the dimensions are of this data frame? Or just a wild guess of how many rows it has and how many variables? I'm going to pause in the chat right here, make sure you're following along. Anyone got any wild guesses of what this is going to return for the amount of rows and the amount of columns when I run this? It's going to return 2 outputs for dim, which is going to give me the dimensions, the rows, and the columns of this data frame, which is like, you know, how big is this Excel spreadsheet? Like how many rows does the Excel spreadsheet have? How many columns does the Excel spreadsheet have? And so what are we going to get right here for the dim, which is the rows and columns of this object, which is the customer data frame. Once again, we're just looking at an Excel spreadsheet. Just be like, I'm looking at an Excel spreadsheet right here, and how many rows does this have? And how many columns does this have? So when we run dim, it's just going to tell us, oh, your Excel spreadsheet has 1,551 rows and 10 columns. Kind of redundant. You can do encall right here. Once again, if you type 3 letters, autocomplete kicks in. I don't like the capital encall. It's weird how the two work in tandem. I use lowercase encall. This gives the number of columns right there. N row. Not n rows, though. Be very careful. It's not n rows. It's n row. Is going to give you the number of rows. And now if we want to view the start of this data frame, what does head do? Head gives you the first 6 by default of any object. So let me ask a question right here. If I run head letters, type it in the chat, what are the first 6 letters of the alphabet? Let's see what head does for head letters. It's going to give me the first 6 of anything I put in there. So what will head letters do? Head data frame gave me the first 6 rows of the data frame. So what will head letters do? Remember, it's going to give you the start of it. So head says, give me the start of something. What will this give me? Type it for yourself and check it out. And remember, I'm saying it'll give you the first 6 of any object. Letters are letters. That's what letters are. Don't worry about the quotes. I mean, we do need them, but just think about what it's giving you if you ask for the first 6 letters. What does head letters give you when you put the letters inside the head function? You're saying, give me the first 6 letters. So what will that return? What will head letters return? Put a little chill music on here. Thoughts? The first 6 letters. I have stumped everybody. 50 points on the line. What will this return? Someone said, Brian, you're not offering points. We know to give answers if you offer points. What will this return right here? Try writing yourself. Nice job, Angeli, right there. Yep. So how about this, though? Really easy to tightly answer this one. What is this going to return? I've added a second argument here. And the second argument is, give me the start of the letters vector. So that says, give me the start of the letters vector, but only give me the first occurrence, the first element. So what will this return? If I say, give me the start of the letters vector, but only give me the first, what will that return? Hey, you're right, Daniel, you're getting it. That just gives me the start. Well, if you have head, you also have tail. So what will this return? This says, take the letters vector and give me the last element. What will this return? Great job, Rachel and everybody. Another 20 points, chat. Keep it up. You have to practice. You have to be like thinking it through. You got it. What's this going to return? I'm just keep throwing those points. What's this going to return here? The tail of the letters vector with a second argument 2. What will this return? Don't worry about the quotes. I'll know that you're saying like quote this, quote this. So you can see the letters vector right there. Or I could trick you. You ready? Watch this. Letters, capital letters. 50 points on the line if you can tell me exactly what this returns. Try to be as exact as possible. And we'll point out some small things right here. Now you notice I changed it. It's no longer the letters vector like this. It's the letters vector like this. So it won't just return Y. You're close. You're close, Daniel. So close. Daniel, I'm turning those 50 points for going on a limb right there. It's not going to return just Y. It's going to return, William got it, YZ. So this right here is the amount of elements it's returning. If you want Y, you could do this. And that returns, oh, that's E. This returns the 25th element of the letters vector. So little differences right there. Is this making sense what head and tail do? Like if you go to this, who can explain what this does right here? Returns... Who can complete this sentence right here? I'll even blank that one part out. Who can complete this right here? When I run this, it's going to return the what? That's about right. Who knows what this is going to return? So when I run this, it'll return what of that data frame? I'm going to run this code right here. Because it's a data frame, it's going to return... So this is no longer letters. Close. First 3 what of the data frame? Here, I'll let you see it. William, 20 points right there. Great answer, William. First three rows. Does that make sense? It returned the first 3 rows. And then this is going to return what? Just put one word, just change it to another 4-letter word. This is going to return what now? Like what? This doesn't return the first 3 rows. This returns the... Just reverse it right here. This returns the what? Just tell me the one word that I'm looking for. It's not going to return the first 3 anymore. It's going to return the... You got it. Everyone's doing great right here. The last, Zachary, great job right there. Zachary, excellent work. Is it starting, like you see, these are the last rows right here. Remember, if you look at the data frame, you can tell it has 1,551. These are the last 3 rows right here. And that just tells you the row number you're looking at. Here we go. This is where Shiv said, got the big questions on this. Show row 27 on the data on the screen. What is the amount spent for this transaction? You want to know something? Here's the easiest way to do it. If we go down here to row 27, you can go to row 27 and you can look at the amount. Whoa. Let's not do it that way. That's not doing coding though. Let's go here to the data frame. Here's a very important note to take, and I want you to look at a cheat sheet right here. If I go to the customer data frame, how can I reach inside and get these vectors out of the customer data frame? How could I reach inside and get these vectors inside of the customer data frame? I just want one character in the chat. How could I reach inside this data frame and be like, let me get a vector? Great job right there, Shiv. $, you got it. And look what happens. The autocomplete turns on right here. So we want from the 27th row, what is the amount spent? So we need, what is the amount spent? I think it's just amount, right? And then let's just look at this. Okay, so we got to go up here. Brian, this is about as long as before. 27th. So 25, 26, 27. We've done it, but what is this? What is this? The square bracket. Zachary's got a hint right there. If we go here and put a square bracket, which these are over here, the positions, we could actually just go to the 27th element. Zachary, great job right there. Zachary, that's worth some 50 points. Amazing answers, Zachary. You're right. If we use the square bracket, we can just go to the 27th position. There it is right there. And there's lots of ways to do this question. A data frame is actually two-dimensional. So I could say go to the 27th row, and there's the 27th row. And you can see the answer again. Well, maybe this is too much output for you again. You could say here, just give me the amount. And now we've gone to the 27th row and asked for the column that is amount. If you were able to look at it, which we could also see that amount is the first column. You can see it's the first variable right here. These are 3 solves to the problem. If you know one of these solves right here, like going and looking at the vector and the 27th amount in the row vector, or going to the 27th row and looking at all columns, or going and looking at that specific entry in the 27th row, all of these get you to the answer of 95. But why did I have to enter in 2 things here again for the data frame, but not for the vector? Who can explain for 100 points? This is a big concept. Why am I entering in 2 things for a data frame and 1 for a vector? Here's what a vector looks like. Here's what a data frame looks like. Why do I enter in 2 things for a data frame and 1 thing for a vector? Why do I have to do that? Remember, here's a vector, and then here's a data frame. So why do data frames take 2? Great answer there, Daniel. You are correct. That's it. That's worth the 100 points. You got it. And I like to go at the big points for the big questions that we should know. A lot of people, times people say, what am I learning? And I say, it's just information. My R is being weird. So right here, you'll notice a vector is one-dimensional. It's just a line of numbers. R does its best ability to wrap the numbers around the screen, but if it could just wrap them in a line, it would. So this is not two-dimensional. You don't go across and down. It just wraps around the screen. But the customer data frame is like an Excel spreadsheet where we have here a row and we have here a column entry. So the comma separates out the dimensionality of a data frame. So be very careful. Let's ask this question. What is Brian asking to return from the customer data frame right now? That's so small I can barely see it. R, stop being weird. Ooh, I'm going to reset my computer tonight. What is Brian asking to return? Try to interpret what this means right here. What am I asking to return from the customer data set right there? What am I asking to return from the customer data set? And I'll give you a hint. It's actually the same as this. Both these codes will return the same thing. So think about the code on line 124 and what it's doing. I am in the row space right now. Rows 1 through 5. William, great answer right there. Maybe it's all the points. Let's break it more and give out even more points. This is the row space. And then we have the column space. So we're returning rows 1 through 5. And so that's the first 5 rows. And the same thing is being done if we go right here and return rows 1 through 5. Same thing. Important to know what's going on right there. How about this? We'll do this. Now I'm doing row 5 and only taking, now be careful, up you'll get tricked by that comma. I'm doing row 5 and I'm also taking what? So those are the rows. That's just to help you. Like that's a guide right there so you can see what's going on. I should put the comma over here, right? That's about as best I can do to help you visually. So row 5, I must stop. Row 5, row 1 through 5, and I'm taking columns what? So if you look when we run the code, yep, so this right here glues things together. This is a vector of 1 and 3. So if you were to not put this, it might get really mad. If we don't put the C right there, it didn't give what I wanted. And if we put this right here, it's not doing what I want. I want it, ooh, it's getting like really mad now. We need the C here to take the columns 1 and 3. And now look, this gives right now rows 1 through 5 and columns 1 and 3, amount and industry. Does that make sense? Industry is column 3 if you get that question. But can you make sense of this? Who's like, okay, that makes sense. What if we do this? Interestingly enough, this will only return a vector because I'm only taking rows 1 through 5 and what is in what column. So I'm only taking rows 1 through 5 and I'm just taking column that is what? You can see the name of the column up there. Because columns have names and columns have numbers. So I'm just taking rows 1 through 5 and taking only what's in what. I'm only taking the values from what now? I'm only taking the values from amount. And it returns a vector because that's just a vector. It's just returning for me these 5 values right here. And you can see them right here. That's what's returning right there. Great job. Great job, Daniel. And what if I do this, though? Now we get everything but that first column. So now it returns everything but the column amount. So you can subtract out rows, subtract out columns, lots of options to be had right here. So great work on that one. And we're getting close to done-ish. What is the column name and the number that contains the customer zip code? Hint, who knows customer zip code is what column? So when you do this, if you look, you can do it a pretty complex way. You can make a names of the data frames. And actually, that kind of just gives you the answer. Let's take a look at this code right here. Names is going to be the column names. There's a few ways to do this. You can do names or call names. And all this does is give you the column names. Same code, different things right there. So with this right here, if we put it into a data frame, it's actually going to turn it into a vector. There's a lot we can do with this data frame function, which we might do later on. But notice how names just gives you the column names. Like, here's the column names, here's the column names. So who knows customer zip code is what, put it in the chat right now, customer zip code is what column? Who knows what column customer zip code is? Put it in there. And then if you get a question like this, you can be like, oh, well, is this column? 6, you got it. There it is right there. It's just number 6. And you could even do something, if you really want to get particular, you could do something like this, equals czip. And then we get trues and falses. Oh, did I misspell it? I did. And so this is the very complex way of doing it, and which will tell us where the true is at. So if you notice right here, the true is right here, and I'm doing a logical test. This is I jumped a little bit advanced right here, but we're just testing which of these names right here is equal to the customer zip. And then if I put this inside of a which, it'll tell me where the true is at. Just a real quick comment on this code. If I were to run this code right here, it's going to return 1. It's not because there's one true. It's because there's one element and it's true. It's the first element. If I run this code right here, if I spell false properly, this code right here will also return 1 because true's in the first position. But if I change true to the second position, then it'll return what? If I put true in the second position, it's going to tell me where the true is at. So it'll return what if I run this code now? It's going to tell me where the trues are at in whatever's inside of the which. Which will take a logical, and a logical is just trues and falses. So when I run this, it tells me trues and falses. These are the abbreviations. So what is it going to do when I run this? What will this do right here? Who knows what this will return? Running this code right here will return what output? Thoughts? So the which is going to return the position of the true. Think to yourself, what position is this true in? Previously, the true is in position 1. Now, what position is the true in now? The true is in what position? Position just means kind of the order in the vector it is in. So when we look at William right there, great job, William, another 20 points. You got it. It's in position 2. Now, don't be tricked. Don't be tricked. What is this going to return? What is this going to return right here? This is going to return what? Hint. Don't be tricked. What is this going to return right now? This will return what? 2, because it's just telling me where the trues are at. How long is this vector? How many elements are in this vector? And how do I know this? I could tell you for certain that this vector right here has how many things inside of it. And hint, that's a big hint right there. How long is this vector? Because think, if it's telling me where the trues are at and the last element's true, then I can be like, well, it looks like that vector is this long because it tells me where the trues are at. This is the last element. It's in this position. So the vector is 21 long. Wherever there is a true, it'll tell me where that's at. Like imagine, and think about the application of this. If I were to go to a data frame right here, just doing a quick example real quick, and if I wanted to find people who were 5'10", I could go to height and go to, let's go to 5'10", 70 inches, and I want to see if they are 70 inches. And the people in this survey who are 70 inches tall are these people. I could quickly use this here to subset the survey by going inside the survey and only selecting those rows. And here's a subset of the people who are 70 inches tall. And just to check, you can see right here, we have just subsetted everybody who is 70 inches tall. So this is some of the application on using something like this to find values and be like, okay, let's find these ones, let's find the positions, and let's only take these things. This is everyone who's 70 inches tall, and you could quickly change the code to be like, let's go to 6'3" or something, and then you've just found everyone in the data set who is 6'3". Very quick, very easy, and very applicable to use little code like this. I know that was a little bit quick, just hopefully kind of showing you towards the end of this, because we don't have that much more to do, but some of the things we can do with these little tiny things, like just knowing where trues are at. So we've got right here, using the summary or table, find out how many times this person purchased something on the internet. I believe this was person 27. Let's go find them again real quick. Is this person? How many times this person? Person 27, right? Great job, Daniel, on all those points. Row 27. I think it's row 27. So let's go here. And what am I going to do? The column is internet. So what you can do is you can go to the customer data frame and search for the column internet. And we got it right there. Wait, how many times? Wait. Find how many times this person purchased something on the internet. Oh. I'm losing my mind. We're doing the full internet thing, not just this one customer. But let's go here and go to table of cust and $ and internet. And there we go. How many times did they purchase on the internet? This is a summary of a what kind of variable. So this is your chance to follow along and practice. Industry. So internet is a what kind of variable? Ooh, it's not stored properly, actually. Internet should be a what kind of variable? Internet should be a what kind of variable, and we can fix this. Internet should be a what kind of variable? It should be, and it is working right here like this. It should be what? And I'm going to fix it here. Let's go here and overwrite it. It should be a factor. It should be like, great job right there, Daniel. It should be a factor. So factors are like categorical variables. And so I've overwritten it. We get the same output there, but I'm overwriting it. Please ask me to slow down if I'm going too fast. But if you notice, we get the same output no matter what we do right there. Let's look at this code right here and just see if it makes sense. This code right here is taking the vector internet. So this is a vector inside of a data frame with yeses and nos. And this vector yeses and nos right now, before we change it, is actually words. These quotes right here means it's what's. You can see the abbreviation. I said words, but inside of R, it also calls it what's. So what do you notice right here? What is char? Is that Charmander? Is that you, Charmander? You've been making a lot of appearances today, Charmander. That's all he says. What is that? Is that Charmander? What is CHR? CHR? What does that mean? It's telling us what this data is. And these data right now are viewed inside of the brain of R. So it's telling us what this is. I bet if I do class, it'll tell me what it is. If I run class on it, well, then that will also tell me what that is. How is R viewing this vector right now? It's a what type of vector? And that's the answer to what it is. But what does CHR stand for? Who knows? CHR stands for a blank vector. INT is integer vectors. NUM is numeric vectors. Factors, we'll see those in a second. Those are FCT, I think, something like that. There's a lot of different types. There's time vectors, but CHR stands for character vector. These are characters, strings, words. We don't want words, we want factors. So you can do as.factor or factor, and that just takes this, turns it into a factor, and then we don't just want to turn it into a factor, we want to write into the variable and overwrite it. And we get the answers. There's the answers right there. Make a bar chart. Bar charts are amazing and pretty easy to make. So with a bar chart right here, we're just going to make a bar chart of industry. And we might need to do the same to industry. Industry is not a character, not a factor yet either. So let's go right here. Go here and do industry. And just change this, overwrite, and you see industry becomes a factor now. And with this, we can go here to bar plot, but I want to point something out. You have to put this inside of a table. And so let's expand our view a little bit, and you will be able to see the bar plot here. And I'm going to try something better in a second to make it look even nicer. So this is how we make a bar plot right here of all the industries. I think, one try at this I get. You won't have this, but I can show people how to install this. Will it work? Nope, doesn't like it. We will worry about that at a different time. But this is a bar plot right here, and I think it will work in base R just using the plot function to make a bar plot. There we go. This is how we make a bar plot right here. We just have 3 more questions. How's everyone doing in the chat? I haven't heard from chat in a while. How's everyone doing on the chat? How's everyone doing on the chat? We're dealing with data frames right now. I'm going to slow down, see what questions there are. How's chat doing? Let me know in chat. How are you doing? What questions do you have? People might have already aced the quiz. I don't know, where does it show me how many people are viewing? I shouldn't find out to see that on my stream, and they'll be like, oh, Mubot can tell me. 10 people viewing. Wow, I love it. I love it. Later in the day stream, 10 people viewing. Internet going crazy on campus. I'll take it. Doing good, just kind of learning everything, playing around. Perfect. That's exactly what you should be doing. Exactly what you should be doing. Perfect job right there. So next thing we're going to do is you should see distance. How far customers away from the store is -99 for row 563. This is a bogus value, which means it just shouldn't exist. Replace this value by the number 2 using the left arrow symbol. Show row 566 on 563 on the screen. After this is done verifying the change. This is done very simple by assigning like this right here. We actually have the code right here for you on how to pull up the row and Yeah, I think we got it. If you look, we're going to a data frame with 2 dimensions, and we're doing the distance column. So there's the negative 999, and then we're just going to left arrow into it. Like, this might as well just be X over here. It's just something we're saving into. And if you notice when we run this, it's going to run, and then we can re-look at it, and we can show just that row. So I'll show how to show just a row right there, and we can see that the distance is now 2. So the distance has become 2 because we wrote into this column right here. So we went to row 563, wrote into distance, the distance column, and wrote the value 2 into it. And then this is used to view the whole column right here. Row, excuse me. Row 563 is being viewed by running this code. You could view the distance portion if you want. So that is the new distance we assigned. But it's better to kind of look at the row and see what you have right there. There are many values of distance that are negative 999. Uh-oh. So let's make a subset of the data called cusD that has 2 columns, amount and distance, where the distance are at least 0. Okay, so they're at least 0. They're 0 or higher. Once this is done, find the average amount. This is a tricky one. Find the average amount of the amount column and produce a summary of the distance column. Okay, so we need to make a subset right here. Subset has a few arguments in it. Every argument is going to be separated by a what. When you see me write new arguments, I'm going to change what I'm talking about. I'm going to say, like, let's make a subset of this. Then I'm going to change what we're doing to say, and let's put conditions of this. When I put a new arguments are always going to have what's inside of R. This is a key learning objective that you should know. New arguments will always be separated by a what. Just put that one character in the chat. New arguments will always be, I haven't thrown points in a while. New arguments will always be separated by what's. So I'll start it out right here. You ready? I'm going to store into sub, or cusd it wants it called. So that's what we're storing into. And store into is left arrow. So I'll drop this in the chat right here so people can work with it. So we're going to store into. Great job, Angeli, right there. Excellent work. Thank you so much. And then we're going to use the subset function. We're going to let it autocomplete right here. And then the first thing it asks is, what are you subsetting? We are subsetting the customer data frame. And here's what I'm going to do. I'm going to run it. It runs. That's awesome. So always be running your code. Code in little bits and get your code running and make sure just it works along the way. When I put in a comma right here, Angeli, thank you so much. When I put in a comma, I've gone into a new argument. Now I like to sub-indent my code. It's just the way I code. So I hit enter. It'll read through this and go to the next line. What I need to do is write a condition right here. We're looking at the distance. I don't have to use cust $. It already knows I'm inside of cust right now. I want a distance that is at least 0, as in greater than or equal to 0. Now what I'm going to do is I'm going to go look at cusd, and I'm going to go look at distance. You can actually sort it inside of here pretty quickly, and you can see, whoa, all the distances are greater than or equal to 0. Does that make sense right here? That we have now sorted, or just looking at it, we can see we have distances greater than or equal to 0, and we look to be pretty good. We've now taken a subset of people who have a distance of at least 0 right here, so we seem to be good. So now we need the mean amount. Well, is it just giving us the code? This is how we take the mean, and as long as they're not NAs, if there was an NA, which I'll show you what happens here, let's go ahead and put an NA in, and NA stands for missingness. So if we were missing this customer's amount, it won't give you the amount. Now be very careful. I have altered this data set right here. So if you have to find the mean of something, this is a different data set now. Don't do this. Don't do what I'm about to do right here. If you want, don't run this code. This code alters what we have. So you should see something like this right here. Oh, did I already break it again? Oh, I don't have that. And there it is right there. But if there is an NA, and what does NA look like? NAs look like the following. Notice right here, the data of this customer is what for their amount? The data from this customer is what? Who can tell me? This is a big learning objective. 50 points in the chat. What's going on with the data from that customer if it's NA? I think it's not there. It's whatting. The data from that customer is what? Like you're like, oh, we don't have that. And oh, let's go do this. The data from customer 1 is now what? The data for customers 1 through 10. I'm destroying the data. The data for, you would not normally do this. This is not what we normally do. It's for examples. The data for amounts for customers 1 through 10 are now what? This is not a word. Notice how it is still a numeric vector. The data for customers 1 through 10 is what now? So it is a vector. This is a vector of values. But do you see any data for them? What's NA mean? What does NA mean? What's it mean that their data is NA? It's gone. Think about it, it's gone. It's I don't want to say the word. I want you to think of it. I want you to think of it and put in the chat. Be like, oh, that data's missing. What do you think it is? Missing, Zach. Great job right there, 50 points. And awesome money, everybody. It's missing. It's not there. It's gone. It's missing. We just don't have that data. It's not there. I deleted it. You don't want to purposely make missing data. I can bring back that data nice and quick by reloading everything by doing the run all chunks above. Oh, I just deleted it again. We can bring it back again and not run that. And so now you'll notice right here, we actually do have the data. But if you have missing data, the function for mean won't run. You need an additional argument. You got it, Mon. Great work right there. And now this is na.remove. So with this right here, it removes the missing values so that you can run this. So we're going to put here na.remove equals true, and notice it runs. If you don't have na.remove equals true, it'll set it to false, and you won't get any values. This is only needed when you have missingness. And you'll have this a lot of times like, oh, let me sum up this vector. Let me take the sum of this vector. Oh, it's missing. What? Let me take the median of this vector. The median of this vector, it's missing. Well, you need the argument na.remove equals true, and that just removes the NAs. Like how to handle the NAs. The missingness will be removed. Summary of the distance. Oh, cool. Well, here we'll do the right answers, right? Delete that. Run this, and now that's kind of not even needed, but that's the answer for that. Summary of the distance column. So let's go here to summary. We're going to type a few letters, let it autocomplete. Go to the cust data frame. Oh, we're doing cust D, right? There we go. And the distance column. And notice that the distance column right here does give us the summary and all this good stuff. If there was missingness, it would actually report the amount of missingness in there. I'll show that. It's just kind of important to see. So I'm going to create more missingness, 100 values of missingness this time. And so now when we rerun it, it'll tell you that there are 100 missing values. So this information is reported in a lot of ways. And you can see the actual summary right there. Last question, dealing with sequences. Let's put a cut. I'm hoping this has helped a lot of people tonight. We'll put a little chill music on right here. But let's go do this last question with sequences. Here we go. Optional. We like optional questions, right? Make a vector called y that is a sequence that goes from 8 to 103 in increments of 1.8. Note the sequence will actually end at 101.6, and that's because if it doesn't reach that last increment, it won't continue. Using the length function combined with the which, how many elements are greater than 90? So there's a lot of steps right here. First thing we want to do is use the sequence function. Sequence function right here has a few arguments. From, to, by. So we're going to use these versions of it right here. If you're ever wondering how to use an argument inside of R, I should have mentioned this at the start. You can always go $SEQ, and you can view how to use an argument or a function inside of R. So this is the notation on it showing you how it's used. They oftentimes have examples at the end, which I oftentimes go down to, and then kind of work with them to see how mine is working. So you can see different versions of it right here. So we want to start from 8 and go to 103. And we want to go by 1.8. This will create the sequence. But I want someone to tell me how to save this. How can we save this into like X, which we haven't been using X in a while? Or we can save it into Z. Who can tell me what to put before this to save it into something? Hint, save into Z. Let's try saving this into Z. So who can tell me how to save this into Z? How could we take this and save it into Z? Nice job right there, William. Worth some 20 points right there. Great job, and Mun. Saving it into Z right there. You got it. We're going to save into Z. Now, this is just going to take and put Z in the global environment, and you can see Z is the vector. Now, we want to find out how many of the elements are greater than 90. Well, here's the answer. 1, 2, 3, 4. 5, 6, 7. Class over. Well, we need to do this with code. Now that we have this called z and we can just run it at any time, let's ask, is it greater than, or is it equal to, elements are greater than, how many elements are greater than 9? Yep. So there we go. Here's a logical. Does everyone notice how we've taken our vector and run a test to see if it's greater than 90? And you know what's absolutely amazing about this? There's a lot of ways to do this. But I want you to write this down. I want you to put this in the chat. If 5 people say this, I'll give 100 points. R sees trues and falses as 1s and 0s. R sees trues and falses as 1s and 0s. Put that in the chat because it's going to really help us right here. R sees trues and falses as 1s and 0s. It can just be called whatever right there. R sees trues and falses as 1s and 0s. Put that in the chat because we're going to be able to do something really easy with this. R sees trues and falses as 1s and 0s. Nice job right there. I want to make sure everyone knows that because that's huge to how R sees these things. I'm going to throw the 100 points on I'm going to go out on the honor system right here that we're going to get a few more. Great job, Wilton and Angeli and William. So you know what we can do? Just take the what of this vector. If these are all just 0s and 1s, what could I do? If these are all 0s and 1s, what could I do? If these are all 0s and 1, I could just take the what of the vector. Because these are just 0s and 1s. Like, just so you know, as dot numeric, if we turn it into a numeric vector, it literally, oh, there's no Brian with lowercase n. It's 0s and 1s. That's how it sees them. So why don't I just take the what of the vector? Just think. 3-letter word, I can just take the what of this vector because it's trues and falses. They're just 0s and 1s in the brain of R. So what could I do right here to just find the answer? You got it. Just think 3-letter word. Well, Brian, if it's 0s and 1s, just take it. I think there's 0s and 1s. Just boom, Angela, you got it. You got it. You got it. Great job right there. Did I say 7 or 8? It was 7. So there's a lot of great things we can do with this. I'm using a different survey right here to take a look. If we wanted to find out, like, if people, let's go to GPA or something. If we want to go to GPA, is it GPA? If we want to find out how many people have a GPA that is 4.0, well, then we can take the sum of this vector. And there were 29 people with a 4.0 GPA. How many people had a GPA less than or equal to 3? There you go, 268. So you're just adding up the trues and falses when it checks to see someone's GPA is greater than, less than this amount, or not equal to. These are the individuals. You can also do it the longer way of doing this. I'll show the long way, which is a lot less fun. Here's the logical vector. Here's the positions of where the trues are at. We did this earlier. So this is going to return back to me like 53, 52, 51, 50, 49, 48, 47. There it is right there. And then now we want to go to the length of this, and this will return the same answer as we got previously, which is 7. Which is just taking the positions and finding out how many positions there are there of trues. So which finds the positions of the trues, and then we can find the length of the position of the trues vector. Little more complicated. Easiest way to do it is take the sum. You can also find out the percent of trues by, instead of using sum, use mean. So that's the percent of observations that are greater than 9. I think that's got it. Really good coding night practice. I want these to go like an hour, hour and a half. But hopefully this helped out a lot. We'll put on a little music and we'll end off here. What do people think? Any thoughts on our first coding night? Has anyone gotten 100 on the activity? Who's got some hundreds on the activity? And did this help out? This is just kind of like pure coding night practice. This will hopefully make you a better coder. You got to sit down. You just got to practice. Are you going to do the walkthrough of assignment 1? We've been doing a lot of assignment 1 during office hours. Swing by office hours, especially tomorrow. And I don't do a full walkthrough like this on the assignments. I do like different parts. But the goal is every week we will do an activity like this, and you'll have a full video walking through each part of this. Basically a key. You still got to practice. You're welcome, Zachary. So I won't do the full assignment or else I'd be doing all the work. So the goal is that this helps out a lot with the activities. So, and then you're like, okay, I got to help for the activities. I can go look and review and practice. Activities are practice and homeworks, but I do work homework problems during office hours. We already got today's video labeled. Thank you. I think they were in the chat earlier. Was it not? Because I saw them in the chat here. You'll know who you are. Charlie, I think you posted the numbers. Yes, nice job. Hopefully some people got some hundreds. I'm gonna head off here in a moment to eat some dinner. Well, I think that's got it. Keep up the great work. Keep practicing. You'll get better and better. By the end of the class, you'll be like, man, coding's easy. Can we just code? I don't want to study. With that, Puppet Shark, say bye, everybody. That's all he says. Bye for now, everyone. Bye.